AI agents are managing portfolios on-chain today, not as a concept, not as a roadmap item, as a live reality. Wallets with programmable execution logic, autonomous agents running systematic strategies across DeFi, tooling for agent-driven financial flows maturing faster than most people expected. The problem is that most DeFi infrastructure was built for humans. Today, I want to talk about why that gap matters and what the right execution infrastructure actually looks like from an agent's perspective. When a human trader opens a position, they can adjust in real time. They see the price, judge the slippage estimate, decide whether to proceed. An agent can't do that. It has function calls, expected values, and error conditions. The interface is irrelevant. What matters is whether the system behaves predictably. So let me lay out what agents actually require, not as UI features, but as API properties. Deterministic pricing. The agent needs to calculate expected execution cost before submitting a transaction, not an estimate based on current curve depth, a reliable reference that doesn't change between calculation and execution. If the price the agent computed when it made the decision differs from the price it gets when the transaction lands, the agent's model is wrong. And a model that's systematically wrong is a model that loses money. Predictable margin requirements, collateral ratios, maintenance margin, liquidation thresholds, these need to be calculable from on-chain parameters. An agent managing a portfolio needs to know its liquidation distance before it happens, not after. Reliable liquidation mechanics. Settlement rules need to be deterministic and governed by on-chain protocol parameters, not by LP behavior, not by external capital dynamics. An agent needs to know what happens when things go wrong before it opens the position, not discover it mid-trade. Composable collateral. An agent managing a multi-asset portfolio shouldn't have to pre-convert assets into a single denomination before each trade. Every conversion step adds latency, cost, and failure surface. These aren't demanding requirements. They're the baseline properties of a well-specified API. Most DeFi perp infrastructure doesn't meet them. Let me explain why AMM-based systems specifically create problems for agents. AMM curve output depends on the state of the pool at the moment of execution. If the pool moves between an agent's calculation and its transaction landing, actual fill differs from expected. For a human, that's acceptable variance. For an agent running a systematic strategy, the variance accumulates across every execution cycle. Over 1,000 trades, small per-trade slippage becomes a significant structural drag. Then there's MEV. Agents submitting transactions to public mempools face the same front-running and sandwich attack exposure as any other user. The difference is that a human can intuit a degraded execution environment and pause. An agent follows its logic. If the logic assumes a price that the actual fill doesn't honor, the agent executes its strategy against conditions it didn't model. LP-driven liquidity changes add another layer of unpredictability. Pool depth changes as liquidity providers deposit and withdraw. An agent relying on particular execution quality may find conditions different when its transaction lands, not because the market moved, but because the LP base shifted. There's no parameter the agent can query to know in advance whether LP capital will be present. The common thread: AMM-based systems expose agents to uncertainty that originates outside the market itself. From pool dynamics, mempool conditions, LP behavior, these variables aren't predictable from protocol parameters alone. Oracle-referenced execution with protocol-managed settlement is structurally different. In LeverUp's architecture, the price is determined before the transaction. Execution references Pyth Pro Oracle feeds rather than deriving price from AMM curve formulas. An agent can query the current Oracle price, apply the protocol's fee parameters, and calculate expected execution cost using the same inputs the protocol will use to settle the trade. The price it calculates is the price it gets. No curve slippage. No pool state uncertainty. Margin requirements are calculable from on-chain parameters. Collateral ratios, liquidation thresholds, maintenance margin levels, these are protocol functions. The agent queries them directly and models portfolio risk without making assumptions about LP behavior. Settlement is deterministic. The protocol-managed virtual liquidity architecture handles position settlement at the protocol layer. An agent submitting a trade against a well-specified protocol gets the same settlement behavior regardless of what LPs are doing elsewhere. The system is governed by parameters, not by behavioral dynamics. The practical result: an agent can construct a complete execution model, entry price, cost, margin required, liquidation distance, before sending a transaction. It can validate that model against on-chain state at submission time. It can handle errors systematically rather than ad hoc. Any collateral matters here too. An agent managing a portfolio across MON, LVMON, and USDC in a stablecoin-only system faces a forced choice. Convert everything before opening or hold assets idle. Every conversion is a transaction, a cost, a latency window, a point of failure. With any collateral, MON and LVMON are accepted as collateral directly. The agent retains economic exposure to its collateral assets. The conversion step disappears. Fewer transactions means fewer failure points, lower total cost, shorter latency from decision to position. Now here's the thing that I find genuinely interesting about this architecture. LeverUp wasn't built to serve AI agents. It was built to solve problems for human traders, eliminate LP coordination overhead, provide Oracle-referenced pricing, make margin requirements legible. What's interesting is that the properties that solve those problems for humans are exactly the properties agents require. Deterministic execution, because humans need to know what they're getting, is the same property agents need to build a reliable execution model. No LP coordination overhead, because human traders shouldn't depend on capital they don't control, means agents don't depend on it either. Oracle reference pricing, because market-referenced execution is more predictable than curve-derived execution, means agents can calculate costs before transacting. The infrastructure wasn't designed with agents in mind, but the architectural choices that made it work well for human traders produce the API properties that automated systems need. As autonomous financial agents become a more significant source of on-chain trading volume, execution infrastructure designed around determinism will have structural advantages over infrastructure designed around human interaction tolerances. That gap will matter more, not less, as the agent share of trading grows. For the full execution layer architecture, the LeverUp as Financial Execution Layer article is the companion read. And if you want to understand how any collateral's multi-asset collateral framework works in detail, the any collateral piece has the mechanics. Both links are in the show notes. As always, not financial advice. See you in the next one.